All right, section 3.2, we're going to talk about reflections and glide reflections. And for starters today, we're just going to talk about the reflections part. We're going to start with a description of that. So a point P is reflected over a line L, and its mirror image is a point P prime. So that's our setup. We call L the reflecting line. If our point is actually on the line, then it's its own reflection. P is equal to P prime. If it's not on the line, then the line will be a perpendicular bisector of the segment P prime. The reflection also reverses the orientation of the pre-image. And a reflection is an isometry. So, let's start with the last piece up there. What did you learn last time is isometry mean? What does that mean? Preserves the length and width. Can anyone else add anything to it? Distance, another way we think about it. Okay, so an isometry doesn't change sizes. Length, width, distance, right? Doesn't change the size of something. It might change the orientation, so like when you look at a mirror, right? You wave your right hand, the mirror is not actually waving its right hand back at you, so to speak, correct? It's the reverse image. That's the orientation that this is talking about. Let me actually draw a line with a reflection point so that I can talk about the perpendicular thing that this references. So let's say, for instance, that this is your line L. And our point P is right here. If P is reflected over line L, it would be reflected to approximately here. And what this is talking about is that if you were to connect P and P prime, they would happen at a perpendicular or a right angle here, and it would be halfway in between. So the distance here would be the same as the distance here, if it were drawn well. Now there's a lot of ways to construct reflections. One of the ways that your book references, and this is kind of a nice one, is to fold along a reflecting line. You've probably done something like this before with tracing paper, right, where you try to get the same image on the other side. This one's the image of a tree. I'm sure that I mentioned it in the last video, but just as a reminder as well, the pre-image is where we start, the image is where we end. So you see the pre-image of the left-hand side of the tree over here, and the image is the green part on the right-hand side that is reflected over that blue line. So using tracing paper is one way to do that, and folding. Another way to do that, with tracing paper. Here's another example with the tracing paper. I just didn't have this image on there. And so this image doesn't actually, if you take a look at this one, the image comes all the way to the edge here, right? Like the image is touching, but over here, they're a distance away. And that's totally fine too. This distance right here gets mirrored over here to this distance away. And so you can still fold. It doesn't have to be folding along actually something touching your object when you're using the tracing paper. I like this particular imagery at the bottom because they actually show you what happens with the letters themselves. Do you see what they did with the B here? And how they showed you that it actually reversed the image of how the B looks as well. They like legitimately flipped it over. They did it with the A and the C. They're trying to show you the image itself getting reflected over, which is kind of cool. And they're the image points, they've labeled them as primes. All right, so a couple of examples, and then we will pause for today. So taking a look at, we'll just do this example. Actually, this is a good place to stop. This is a dot grid. Dot grids are not easy to do always with our reflections, because folding along them can be a little bit more tricky than you imagine it to be. So if you take a look first at the picture, we've got one point that's actually on our line, correct? So this point right here, we'll call it P, won't move. All right, so it's going to be its own reflection. The next thing that we're going to do is we're going to take a look at how we can think about this as the image being folded over. If you were to take your paper, in fact, you know what, let's do it that way. I would like for you to take your paper as best you can, pull it out of there, and see if you can fold it along. Mine's blue, yours is probably gray, depending on. Fold it and see if you can figure out where it should be along your dot grid. I can't fold my paper. I mean, I can fold my paper. I can't fold my iPad. I know, why not? What's up with that? All right, so after you fold it, you might be able to trace it through to the other side and then retrace it again one more time. I don't know how many times you're going to have to retrace to get it to show up on the right side of your paper. When you get it show up, compare with somebody next to you and make sure that your image kind of showed up in the same location. Do they match everybody's nearby you? Good deal. So your image should have looked like this, does it? All right. Now, if you had drawn this image from the get-go, you might not have drawn it quite like that, because it's at this angle and it feels kind of awkward. So what I'd like to show you is why it makes sense from our definition by point from where we had started talking about this perspective. So we're going to start with the point over here in red. This point, if you look at this line segment, is perpendicular to the blue line, correct? So if I were to continue going perpendicular to the blue line in the other direction, the same distance, it will be reflected here. That's probably the easiest point to see because the perpendicular is drawn in. So this point's over here, so that one's kind of cool. Another point that makes it more difficult to see would be, say, this point. Well, that point doesn't lie along a line segment perpendicular to the blue line, right? If I were to draw it, it would be right here. And then if I were to keep going, I would end up over here. But that's not really part of my image, so it feels awkward to draw it in that way, doesn't it? But it fits the description, right? The description over here, when we originally started, said that if I were to take the point and I would take the image of the point, it will be a perpendicular to the line of reflection. So it works, and it's there, but let me talk to you a little bit about how I think about drawing it when I'm unable to fold my paper, or if I want to verify that the paper fold made sense. This piece we're good with. Nobody seemed to have any trouble with that one. If you take a look at this particular diagonal, I'm going to the left one, so here I'm going down one. I'm going to the left two, so here I'm going down two. The distances match. One's moving directly to the left and one moves directly down. And this is happening because it's along a diagonal, right? This blue line is along a diagonal for my dot grid. If I've gone and drawn in these two pieces, which we've already agreed upon at this point now, if you take a look next, you would be going, use a different color, up from that point, and we will go right from this point, and then we will end up connecting the last two pieces that we have for our final image. The image needs to be congruent to what I started with, right? It means the same image. Because it's an isometry. Isometry preserves the distances. It preserves sizes. So all of my sizes, my distances are being preserved hence all of the things that are congruent to what they originally were.